Hello and welcome to this presentation on establishing a rate structure. This is one in a series of presentations on the operation, maintenance, and management of water and wastewater utilities serving Native American tribes and Alaskan Native villages. This presentation provides an overview of the different types of rate structures, the components of rates, as well as some considerations that go into developing a rate structure. So just a brief overview of what we're going to discuss today. We'll go over revenue requirements, cost allocation, how to distribute costs to customers, how to design rates and administration of those rates, financial stability of a water utility, and the rate setting step guide, which is also presented in the asset management presentation. A utility should have a couple of goals when setting up rates. They should fairly allocate costs to the type of user. They shouldn't be disproportionate or uneven to any user, individual, or business. So how do you do that? Do you charge by the gallon, or do you establish a flat rate? Or both have pros and cons to each way of charging rates. And again, we mentioned before that rates should be stable. A fair and stable rate can create integrity and trust, hopefully, from the utility user, the customer, to the utility and the water provider. So what do you do first? Well, the first thing to do when setting up a rate is develop a general rate setting action strategy. And how do you do that? You want to gather your budgets that you've established historically, budget reports, customer related records, any relevant record that will help you set up a rate. And once you've gathered or organized this historic financial information and operating history, you can start to establish a rate. In doing that, you need to determine your total annual revenue requirements. So how much money you got to bring in to run your system, to pay for your salaries, your equipment, your water supply, things of that nature. And how to allocate the revenue to costs. Which part of revenue goes to salary, what percentage of revenue goes to repairs, etc. How to distribute those costs to your customers. Again, flat rate or rate per gallon, and designing rates for customer classes to recover your costs sufficiently to run your utility. What are your revenue requirements? You want to determine your revenue need to identify the expected cost. Requirements that actually reflect the cash needs for a utility is the first step in the plan of attack for setting rates. If you have a good budget and spending plan, this should be just an extension of your existing budget and accounting practices. You're just trying to determine the cash need and timing of expenditures. You need to understand your expected revenue monthly, quarterly, and annually, so you can plan for short-term and long-term cash needs. And debt services or borrowed funds, do you have to pay those back from banks? Your equipment, are you rehabbing or replacing or expanding? And can you afford a cash reserve? If you can't afford one, you should at least plan for one. You want to project the future needs based on past experiences. Record logs on project repairs and things that you've done in the past that you've kept track of so you can plan for the next year for operation and maintenance needs. Major revenue requirements can be split into two major categories: your operating expenses and your capital costs. Operating expenses for running the plant, surface water reservoir or groundwater treatment, collection and distribution systems, and costs to maintain the facilities and equipment. Also, the expense of paying the administration and personnel, salaries, costs for running the office, supplies, things of that nature. And costs to maintain the facilities or operation and maintenance costs, things that should be in your annual budget. Capital costs are generally associated with the assets of the plant, such as the treatment plant itself, buildings, the pipes, the pumps, physical assets. Do you need upgrades? Do you have equipment that needs to be repaired? Do you need upgrades because of a new development? These are major expenses that you need to plan for. And again, debt services. Do you have loans or grants that need to be paid back? Cash reserve is always good to have on hand. And you also need to plan for forecasting expenditures. You should have a general sense of the things that you've repaired, replaced, money you've spent on the system. These are things hopefully you've tracked over the years in a record log or in a worksheet that provides you historic information to allow you to project what you'd need in the next coming period of months years and a 5 to 10 year plan. These are all items in a capital improvement plan, which we reviewed during our asset management presentation.
And this information basically allows for forecasting expected decreases in water demand
or system growth. You have to consider inflation and budget that CIP or capital improvement plan for improvements and upgrades. There's two basic accounting methods for establishing revenue: cash and utility basis. So if you're on a cash basis and you're publicly owned, then a utility can raise money to cover costs, including debt services. But if you're a utility basis and you're an investor-owned utility, you may be able to use your equity as a profit. In general, publicly owned utilities don't show profit, and your utility could operate in either manner. So then, how do you allocate costs? Well, not all system users make similar demands on the water or wastewater system. So if you use more, do you pay more? Or if you use more, do you pay less? Consider that some customers with high flow rates may need more attention. They may have more service calls, they may need larger pumps, larger mains, may need additional storage, so they should pay more for that additional service. And they could have a peak demand. They could have demand at a certain time of the day. If it's a casino with a concert venue or a stadium, they may need more water when that stadium is full of people, and you could charge more at that time of day.
So now let's look at what causes these types of costs.
Water is the biggest commodity, but you need chemicals to treat the water. And how much do you use? You have demand. The water provided. It needs to be treated, needs to be stored somewhere, potentially in a storage tank, collected or distributed to the user. You have customer costs, so meters, billings, administrative costs, collection of money, and accounting. These are two separate costs that we'll go over here moving forward with a few examples. So keep in mind that the water is the commodity cost, and the meters and the billing are demand and a customer cost. And you also have fire protection cost, again, which is demand related. When there's a fire, you need it, and you can decide whether a utility charges for that water use to fight a fire or not. So we've went over some types of costs. Now how do we distribute the cost? You could establish different classes of customers or type of user by demand or peaking characteristics. Plan for either peak or off-peak use. And who are your customers?
Do you have residential and/or commercial customers?
Do you have any industrial users that use a lot of water, or agricultural as well? And you're also providing for schools and government offices and office buildings. And should they be charged differently? Something to consider when you're building your cost allocation. You now have to design a rate to recover the expended cash or money spent to run your system. And rates should be based on the cost of the service. They should be split equitably among the users. Now, equitably might mean different things to different users. In some way, each user should be charged for their water or wastewater use. So there are different rate structures. We're going to mention here 6 of the most common rate structures. You've got a flat rate, as mentioned, fixed fee. All users pay the same. In this case, you don't need meters. There's no reason to determine how much flow there's being used for each individual user. In some senses, this could be easier to maintain. You don't need as many employees, potentially, to read meters. We'll talk about a uniform rate, which is based on consumption. So the amount you use needs to be metered, and you charge by the flow. And that's what we'll go over here today. A decreasing block rate, so the more you use, the less you pay. Potentially benefits the biggest users, industries, agriculture. And there's no reason to conserve. So in that case, if you had a system with some leaks, the user wouldn't necessarily care that they had a leak, or maybe not even repair it if it wasn't impacting them directly. And some percentage of that volume of water could be lost through leakage, and users would have no reason to fix it because they were paying less for using more.
Another rate structure is the increasing block rate. The more you use, the more you pay.
That does certainly seem good for water conservation. A seasonal rate, could you use or charge more during peak season? And a single tariff rate, which is generally used for larger systems. So if your smaller system is consolidated into a larger system that has a single owner. Even if they're not connected, you may, as a larger utility, let the small systems establish their own rate and pay the larger utility a tariff. Some basic considerations when establishing a rate structure. Use simple methods for small utilities. Keep it simple. Doesn't need to be too complicated. If you're going to charge commodity-based or flow-based, every user should be metered, and you'll need good historical data to get information on various user classes. Now again, this is up to the operator and the utility if you want to go flat rate or volume rate. For our example today, in your basic rate components for a volume rate is what we'll talk about. To establish that rate, you'd need the service charge. So basically, how much it costs to read the meter, and a volume charge, costs associated with the commodity or the actual water use. So we'll go over a couple examples here where these two components need to be established and charged to the user. So we'll start here with a case study on a small water utility. Your utility has 2 wells and 1 storage tank. That's the source of the water. 200 service connections, a population of 500 people, and an average daily consumption of 50,000 gallons per day. So that's about 250 gallons per day per connection. And now here we're showing expenses. How would you categorize these types of expenses? In this example, we'd be calling them operational costs. You need various materials and supplies. These are the commodity costs. And in the darker green, these costs are the costs you need to provide the water or the commodity.
They are the power to run the pump, the chemicals, you have the salaries of the employees, and various materials or supplies.
The administration, utilities, and office rent, these would be the customer costs. In a sense, what it costs to pay the bills, put out the bills, run the office, answer the phones. So you've got commodity costs and customer costs. Then if you have a debt service or a loan, you're going to have to pay that back or consider that cost, and repair and replacement costs for equipment. So the total revenue requirement in this example is $66,000. You have a $66,000 required revenue to make your utility run without a loss. So if you have that cost, you need to allocate that cost to certain categories. You have operation and maintenance expenses of $55,000 annually. $32,700 of that is commodity and demand. As mentioned on the last slide, certain costs can be allocated to commodity and certain costs can be allocated to the customer. It's simply a way of allocating costs so they can be tracked separately. So $22,300 of that cost can be considered a customer cost. And again, you have debt service and repair costs. So this is, again, the total amount of revenue required to cover your system costs for the year is $66,000. We split that into 2 categories as mentioned before, $43,700 of commodity and demand costs and $22,300 of customer costs. So how would you determine the monthly meter service charge? There's a service charge and a commodity charge. Here we're going to establish the monthly meter service charge. You would take the customer charge from the last slide, the $22,300 per year, divide that by the number of meters or connections, the 200 meters from the first slide of the example of the case study, and to determine a monthly charge, you would just convert from years to months. If you divide the customer charge by the number of meters, you would know how much to charge each customer. So each customer has a meter that needs to be maintained and read every month. That charge would be $9.29 per month to each connection or each customer. If you know your customer charge, now you want to define your volume charge or your commodity charge. And you can annualize that to make it simple in a way to read it by water use in thousands of gallons per year. So what you would do is take the average daily use, the gallons per day, which was established at 50,000 gallons per day. Convert that to years. If you take 50,000 gallons a day times 365 days per year, this gives you 18,250 1,000 gallons per year. The second step in the process of determining the monthly volumetric charge in dollars per 1,000 gallon. The total commodity and demand cost that we established several slides ago would be divided by the total water use. That total commodity and demand cost was $43,700 per year. Divide that by the 18,250,000 gallons per year. That ends up at $2.40 per 1,000 gallons. Or that could be converted to 0.0024 cents per gallon. When asking utility operators across the country if this seemed right, most agreed that this was a good per gallon cost for producing water. So in this case, our customers would pay the $9.29 per meter plus $2.40 for every 1,000 gallons of water used. So if that's the case, what would the water bill for a customer who used 10,000 gallons of water a month be? You could take that commodity cost and add it to the service cost. The $9.20 plus $240 for every 1,000 gallons times 10,000 gallons. So a customer's water bill per month could be $33.29. Alright, now we'll work through a similar example but for a small wastewater utility having 800 connections or dwellings and a population of 2,250 people. Again, when running your system, you need to know what your expenses are. So the annual expenses to run this system, for instance, have a labor cost, some professional consulting fees, operation and maintenance costs, materials and supplies that must be purchased and used, other various insurance, utilities, travel, and vehicle costs. You may need consultants, or you may need someone to run your emergency generator, a contractor to do things like that for you, and a capital replacement budget cost for things that need to be repaired. So again, you'd need $172,000 of revenue collected to run your system without losing money. In the case of this wastewater system, how do you determine the monthly service charge? You take the total revenue required, the $172,000 per year, divide that by the number of users or dwellings, the 800, and you convert from years to months. That would give you $17.92 per month, per user, to stay in the black and not lose money. We've established a couple of examples of how you can run your system in a way to stay in the black and make enough money. So how do you administer your rates and charges? We talked about different types of rates, but as a utility, you need to be able to justify those rates, whether it be a flat rate or a commodity-based rate. You want to be able to justify your rates if a customer calls or visits. Pictures tell 1,000 words. You could use graphics and presentations, or you could stick them in the bill that show your recent cost performance, show that you're collecting the right amount of money to provide the service, that you're not necessarily making a profit. So you're making enough to pay salaries and replace equipment to, again, protect human health and the environment. You could show the comparisons of other rates to other utilities. These are fairly well available and publicized. And you could take advantage of the Consumer Confidence Report, the annual water quality report that's sent to customers. It's another good opportunity for communication with your user. You could insert one of these flyers that show your financial situation, or potentially include a survey that had been completed over the last year. So how do you plan for financial stability? You need to have a budget, certainly, and look ahead, as has been discussed in this presentation. You need to consider a rate increase, potentially annually. A small bump that avoids a big bump, maybe 3 or 5 years down the road. Better to have a small increase than wait that longer period of time and have a bigger increase. This should show your customer that you know how to operate your system. You've planned ahead and forecasted what your cost should be for replacing your pumps or pipes or assets that needed replacement, and then increases consumer confidence. Talked in the beginning about measuring stability. How do you know that your utility is financially stable and can generate enough money to pay expenses? A couple calculations that can be used are the operating ratio and the coverage ratio. The operating ratio is the total revenue or total amount of money collected divided by the total operating expense. In this case, you want the numerator, or the number on top, being the revenue, to be larger than the denominator, or the number on the bottom, being the operating expense. You want that number to be 1.0 or higher. This would show that your utility is financially in good shape, and in fact most bonds or loans require a borrower to have a coverage ratio or an operating ratio of at least 1.25, which means you have money in the bank. Starting out by getting to 1.0 is a good goal. Just a quick example of how to determine your operating ratio. If your total revenue is $66,000 and your total operating expense is $55,000, your operating ratio is 1.2. So you're in good shape, you're making money, and you're saving for future repairs. And you know what future repairs need to be made because you've completed your asset management steps for your utility. Now we'll get a little bit into budgeting. And the key to a good budget is to have good records from the year before or the year before that, to track every expense, to determine what kind of money has been spent throughout the year. Basically, the tracking in the purchase order system lets you understand how you spent your money over the previous year. And why is that important? You could determine what you'd be spending money on the next year. You'd know if you repaired a pump last year, probably not going to have to repair it this coming year. Again, gets back to keeping good records and understanding what parts of your system are critical assets and what aren't, and which ones have been replaced and which haven't. Throughout this presentation, we've talked about record logs and record keeping. This is an invaluable way to set accurate water and sewer rates. You can prove to your user, your government, your utility, and to your tribal council the amount of money it takes to run your system. If you have an administrative staff to assist with record keeping, it's great to have a detail-oriented, organized person to keep the records organized while the operator's out fixing things and doing their job. And this type of budgeting and record keeping can allow for change or expansion in planning. You may have a community that's growing, you may have to provide more pumps or more storage, and well-kept records could let you set accurate water and sewer rates. So type of records includes equipment and maintenance records, operations, procurement, what we purchased, inventory, do you need more spare parts, have they been used, and personnel, how much each staff person is getting paid. And how long should you keep these records? Well, essentially, as long as they're useful to you as the operator or as long as they're legally required. If you have data from 5 or 6 years ago, it could be used for future design or expansion. And laboratory data should be kept indefinitely. One way to do this is through electronic transmission of data. Some labs will send lab results to you as the operator in electronic format, possibly in Excel, rather than a hard copy, or both. So if you don't have the room to store hard copies, you could store them electronically on a computer and back up that system, saving space. Your local regulatory agency may specify how long to keep that data and/or customer complaint records, and set up a schedule to regularly review the records and throw away those that aren't needed. The Step Guide series, again, is Simple Tools for Effluent Performance. It's a guide series established by EPA. The website is here. It was also mentioned in the asset management presentation. It's a good tool for establishing asset management, as well as establishing how to set up rates. It's designed to help owners, operators, managers of small community water systems of 3,000 or fewer people understand the full costs to provide safe and adequate water to their customers, and how to set water rates that reflect those costs. In this, contact information can be found in Appendix B, State Drinking Water Primacy Agencies, Appendix C, for tribal drinking water contacts, and Appendix D also has state public service agencies. Inside of the step guide, you'll find how to determine your costs and your current revenues, how to set aside a reserve, and the actual revenue required from your customer to operate your system without losing money. It'll assist you with designing, implementing, and reviewing your rate, and this guidance document is at no cost. It can be downloaded off the website of EPA. This concludes our presentation on rate structures. We've discussed the type of rate structures, how to calculate revenue, how to design a rate structure for your utility, and also the tools you can use for developing or modifying rate structures. Thank you for participating in this presentation. I encourage you to investigate some of the other water and wastewater system and operator maintenance presentations that are part of this training series.